This tutorial will take you guys through some of the commonly used components in the curve menu, and I'll also give you a little practical example of how these might be used in your designs. So we'll start off with the analysis toolbar. If you click on that, it's going to collapse down and show you a whole bunch of components for analyzing and evaluating properties of curves. Some of these are really frequently used, and we'll just start at the top. So to begin with, endpoints is a really commonly used component because it's nice and simple. All it does is it just returns the start and end points of a curve. So it'll give us access to those 2 points and we can start doing things with them. So for example, we might use it to really quickly close curves. So we have two curves defining edges, and we can use the endpoints to just draw lines between them to create a single closed curve. Another really commonly used component is this discontinuity component, which returns all of the discontinuities along a curve, which is kind of like saying the corner points of any polyline. So let's have a look at what that does. So there you go, you can see what it returns is a list of points, which are these sharp corners on the polyline. This can be useful for a whole bunch of reasons. For example, we can then find the average of all of those corner points to get some idea of the centroid of our polyline. Maybe we could then start breaking our polyline into triangulated chunks, things like that. Planarity is a really useful component because it'll return the best fit plane through a curve. So if you have a two-dimensional curve, it'll give you the plane that that curve sits in. Now, the other thing that's really useful about this is it works for multiple curves. So I'm going to set all of these curves here, and then I'm going to be able to offset them all at once using this planarity component. Now what happens normally when you try and offset things, if you try and offset things in Rhino, you can only do it one curve at a time. It's really tedious and slow. In Grasshopper it's a little bit better. We can offset a whole bunch of curves at a time. And actually what it's doing here is automatically finding the plane of the curve, so that's pretty handy, I think. But we can use this planarity component to ensure that all of these curves are offsetting in their own curve plane. So that fixed a problem where some of them were offsetting inwards and some of them were offsetting outwards. Now that's pretty useful because we don't need to set the offset plane each time. We can just use this component to calculate it per curve. And then we can do some funky things like creating a planar surface through those curves and our offset curves as well. So we can really quickly create some frames. Evaluate curve and perpendicular frame are both commonly used components as well. They return some properties of the curve at a specified curve parameter. Now next week we'll be talking about parameter space a lot more, so I won't go into it too much here. But let's just choose one curve and have a look at the evaluate curve component and at the perp frame component. So evaluate curve, what that does is asks for a parameter to evaluate. What I'm going to do is re-parameterize this curve so that its parameter space is just between 0 and 1. The start can be thought of as 0 and the end point of the curve can be thought of as 1, and every point along the curve fits somewhere in between. Then we can use a number slider to find a point anywhere along that curve. So if we ask for 0.5, that's going to be the parametric midpoint of that curve. It's not necessarily going to be the midpoint in terms of lengths, because that depends on how these control points are laid out. You can see they're more compressed here, and so this parameter space is compressed. But we'll talk about that next week. The perpendicular frame component will create exactly that, a perpendicular frame at that point of the curve. So that can be useful for creating objects around curves, for example. So I've just made a circle which I know is going to be perpendicular to that curve. Now, I mentioned before that the parameter space of this curve was compressed, and so this isn't measuring real lengths. It's not the midpoint on the curve in terms of length. We've also got components for evaluating the length of a curve. So this is really useful when we're working with real-world constraints like material dimensions and things like that. So we can measure along this curve any length we like. Now, by default, the curve is normalized, which pretty much means what we're plugging in here is a percentage of the curve rather than a real-world dimension. So I'm going to turn that off, and then you'll see that this point is measuring a real length along the curve. So this is 10 units along the curve, 3 units along the curve, etc. And I think that's pretty much enough of this analysis toolbar. Now let's take a look at this division toolbar. So I'm just going to reference these couple of curves in again. And start looking at these division components. So these allow us to divide curves into points or into smaller curve segments. So first let's look at this divide curve component, which divides it into equal length segments, again based on that curve parameter space. So if you've got compressed control points, you'll get more points from this divide curve component. So I'm going to divide these two curves up, and this is really useful for using curves as elements in our parametric model to drive more complex geometry. So for example, we might be able to create some arcs between these points, like so. And then as we update these curves, all of our arcs will update. Now we can also divide curves based on a specific length. So once again, this is useful when we're trying to work with real geometry or real material dimensions. So let's go ahead and divide all of these arcs up into specific length segments. Okay, so we might have arcs with a length of 4. So maybe that's a constraint of one of our fabrication processes. So we can also shatter curves, which means that we can take these points on the curve and break the curve up into smaller individual curves. But I'm just going to continue on with this example. So for example, now that we've got these arcs divided into even length segments, and by the way, it's great working with arcs because it's very easy to fabricate things with them. You can roll materials, produce arcs quite easily. You can cut single circles and then divide them into these segments. So it's quite an efficient way of building things. We can start looking at some of these other components though. And for example, let's have a look in the spline menu, interpolate. Now what interpolate will do, I'm just going to flip the way these points are organized, is it'll fit NURBS curves precisely through lists of points. So that's really useful for creating grids and wireframes and things like that. Unlike the normal curve component, which uses points as control points. So just like our input curves don't fit exactly through the control points that we specify, it's exactly the same using a curve component or an interpolate curve component. We've also got some other components up here like polyline, so that's going to fit a polyline through points, so they'll all be straight line segments, which can also be useful for fabricating things. Quite difficult to fabricate curvy things, quite straightforward to fabricate straight line things, quite straightforward to fabricate arcs. So suddenly we might be describing this fairly complex geometry in a way that we can actually build. Another pretty interesting component that we can use that's in the curve menu is the geodesic curve component, which just creates a curve between 2 points on a surface, which is the shortest possible path between those 2 points. In order to get the component to work, we need to provide a couple of inputs. We need a base surface geometry, so I'm going to use our lofted list of arcs that we were demonstrating previously, and we need a start and end point, which both already exist on the surface. So I'm going to use a clever trick to create start and end points on the surface, which will be covered in later tutorials on understanding parameter space and some of the maths or sets components. So we can evaluate the surface at a particular parameter in that surface's parameter space in order to make sure that we're finding points which actually exist on the surface and ensure that this geodesic curve component won't break. So that's the basic process that I'm going to go through. And I'm going to make a list of points along one side of the surface and a list of points along the other side using a range component, which simply creates lists of numbers between a minimum and a maximum. So by default, a range component creates lists of numbers between 0 and 1, and that's the exact same domain that our surface parameter space has when we reparameterize the surface. And again, these concepts are going to be covered in later tutorials on understanding surface parameter spaces and understanding lists in Grasshopper. So you don't need to worry about it too much now, we're just going to use it as an example. So we can create a set of points along one edge of the surface, and we can create a set of points along the other edge of the surface, and we can create geodesic curves between the two. So you'll notice that even though we have a start point here and an end point here, the shortest path across the surface actually takes a slightly strange route as we try to fit those curves through this part of the surface with a lot of curvature. Anyway, we can go ahead and loft these curves together, change the options to have straight sections, and we can start creating geometry which can approximate this surface out of flat strips. If we wanted to, we could also create sets of points which, rather than going from this side of the surface to this side of the surface, we can simply change the parameters. So I'm varying the Y position of the points this time rather than the X position, and we'll get strips going in the other direction. Okay, so these strips are going to have minimal curvature. So there's plenty of other components in the curve menu that you might want to investigate. There's utility components for modifying existing curves, some really useful things like offsetting and projecting, which we can do parametrically rather than doing one by one in Rhino. There's plenty of other components for constructing splines, polylines, polyarcs, all very useful, and components for blending. Plenty of components for creating arcs and circles in a variety of different ways that you should look at. Typically in Grasshopper there's many ways to achieve the same result: division components and analysis components. So see if you can find components within the curve menu that you can use as an input or an output to the types of geometry that we're already producing in our other examples.